math is that the math that we do in geometry is really not any more difficult than the algebra stuff that we started with those first few days. But what we're going to do is we're going to add vocabulary to it. And the vocabulary we add to it talks about segments, segment length, midpoints, distance formula, bisecting, things like that. But it all stems from being able to do something pretty simple. For example, what I want to be able to do here is just count. So if you look at the square tiles on the floor, I'm going to say that each square tile is just one unit. It's going to count. And I'm going to walk from here to the back row so I can tell them to put away as follows. So I'm going to count from here to the back row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Move away your phone. Okay? So there are 12 squares from where I started to here. You okay with that? Now, did I walk by this being a starting spot and an ending spot? Is this a segment or a line? It's a segment because there's a start and a stop. Okay? If I go 4 squares, which further do I have to go? 8. What'd you do? You subtracted, right? You just did math in your head. All right? You mathed that off the top of your head. You knew that if I had a starting point and an ending point, I knew that from here to here had a distance of 12. I knew that I started here, I stopped here for a second, and I knew that much was 4. Where I started from is where I stopped. Was I still in the same segment? So my points themselves. Yeah, what do you want? The points themselves, are they collinear or non-collinear? Collinear. What's collinear mean? I forgot. Cool. Quad, quaddy. Did I pronounce that wrong? Quaddy. Yes. 2 and 8. Is it an M? Anyway, so are those, thanks, Leo, are those points are all in the same line, right? So can segments be collinear as well? Yes. Yeah. Oh, I bet you know what we're doing for next hour. So what happens here, guys? What happens here is that if I label my points, excuse me. We good? Come on. When I label my points, I just say A, B, and C. Do you guys agree that there are 2 smaller segments and a larger segment? What are the 2 smaller segments? And what's the larger segment? I'm sorry, the whole segment, excuse me. AC, the whole thing. Sorry. So basically what you're saying is that if I go from A to B, and then I go from B to C, what does that have to equal? Letter-wise. AC, and you're right. So what you're doing here is this thing called segment addition. Segment addition works when you have collinear points and basically it goes to this. I'll move it back up here in a second. Some smaller segment plus a smaller segment equals a larger segment. That's really all it is. 2 smaller segments on the same line add up to be the larger. You guys have done this before. If you used a ruler and you had to measure something that was more than a foot, you had to take the ruler, move the ruler, and you would just add however many feet you had to get to some longer distance. Exactly. You were in the same line as you're going down. You're just moving it down. You're adding more to it. Smaller parts add up to the whole. That's all that means. Two smaller segments can be added to equal the whole. And it goes back to the idea that I knew that from here to the back, 12 squares. If I go 4 squares, how many more do I have to go? 8. Because I knew that from A to B was 4, from B to C was something, and the whole thing was 12. All I had to do was subtract, and I got my overall my leftover, which was 8. That's segment addition. That's what geometry does. It takes vocabulary, segment addition, collinear points, and it brings it back to the algebra that you guys all know how to do. Okay? So once you get over the proverbial hump of geometry sucks to, oh wait, 8 plus something is 12. I can do that. It's easy. Okay? Does it get more complicated than this? You can throw variables in, but we know how to solve a two-step equation. You guys have been doing that forever. Okay? The idea behind all of this math doesn't change. What's going to change are the numbers. That's all it changes. Can you take the vocabulary of having collinear points to show that you get what are called segment additions just via the diagram? Small part plus small part equals whole part. That's all it is. I'll show you another one. And then I'm just going to move this around so you can see it better. And in this problem, they tell you that EG equals 59, and then they're going to ask you what is EF and what is FG. That stuff, things that you need to solve a problem will always be given to you. All I did with this case, guys, is I just moved it out of the way so you can see a bigger picture. Because this happened earlier today, I tried to leave it small so everything's on there. People are like, yeah. So, you're closer. Feel that way. Again, we're at the idea that I have two smaller segments that add up to equal the larger segment. The two smaller segments I have here are EF and FG. The whole segment is EG. So using the idea that this is what we call segment addition, what I do is, I write down EF plus FG has to equal EG. Bless you. Two smaller segments add up to equal the whole thing. The smaller segment for EF, according to the diagram, is 8x minus 14. The smaller segment of FG is 4x plus 1. EG, if it's given to us, it is 59. Isn't that a problem that all of you guys can solve? Yeah. Exactly. In order for you to do something first, what do you have to do? One more time. Before you solve this equation, what do you have to do first? Combine like terms, yeah. I'm trying to get them. Yeah. Combine like terms. All right, what's 4x and 8x? What's negative 14 plus 1? Okay. Now what do you do? There you go. Notice the complexity. 13 and 59 is? How'd you get that? Good. Good. See, you made the mistake, but you corrected it. That's how you remember stuff. Good work. Now, this is where you guys will have to start to get used to it. In geometry, It's not always solve for x, solve for x, solve for x. That's algebra. Geometry, it's solve for x, but then do something with it. In this example, it'll ask us to figure out what's EF and what's FG. Well, exactly. In this case, you just have to go back, take that value of x, which is 6, substitute it back in. Use the calculator. What is 8 times 6 minus 14? What is 4 times 6 plus 1? And hopefully, when you figure out those two numbers, if you add them together, you should get 59. If you did it, you know we done goofed. Okay? 8 times 6, I believe, is 48. Subtract 14 from that, we get 34. Does that sound right? Okay. 4 times 6 is 24. Add 1, you get. And is 34 and 25 59? So we did not goof. We're done. That's how the geometry is going to work in tandem with the algebra that all of you can do. Okay? Yes, sir. How to get it? Remember, I said it was given in the problem. And like I said, it was already written there. But for the people in the back row, you wouldn't have been able to read all that if that was like that. So I just blew it out. Next time I have something like that, I'll put it in 2 parts so you can see it all. Okay. This is what it will look like in a textbook. This is what it will look like in a worksheet or anything. They'll have the information for it. Okay? Not terrible? I have 6 problems very similar to this for you guys tonight. I know. Go easy. I think it's 8 through 13. I know. Pace yourself. Okay? You're using, and that's what you're doing. Yeah, you're using that segment addition stuff. Okay? Yeah, well, there's more to it. We just didn't get to all. We ran out of time. What's that? No, we did not. You learned how to do stuff, right? Sometimes I take some, sometimes I don't. You just don't know. Now, what we'll do with this stuff tonight, guys, the stuff that we're setting up today, it's kind of some quick number line stuff, very similar to you go out 12 spots, count how many are in between. I think there's only 2 problems that have any algebra in them. Tomorrow we'll throw in a couple more vocabulary terms within segments. One of them is called a midpoint. Well, if from here to there was 12, what do you think the midpoint would be? How did you figure that out? You knew half of it was there. So if halfway is 6, that means 6, and then the other side has to be 6, so that means it'd be balanced, right? Is 6 equal to 6? Okay. Would that change if there's variables thrown in? If I say there's a midpoint and I know one side has to equal the other side, shouldn't they equal each other algebraically? Same idea. And that's the kind of stuff you get to. You have to learn the vocabulary to know whether or not you have 2 parts that equal the whole, or you've got 2 parts that equal each other. And that's where geometry comes into vocab. Algebra is easy. It's keeping the vocab straight, which is what people have a problem with. Okay? There's a book up here if you want to take a picture of those 6 problems. Otherwise, make sure you screenshot it and get out of here.